So the major objective will be basically covering up and understanding how do we factor out a quadratic and how do we solve a factored quadratic when it is equated to 0. So now generally when you talk about a quadratic equation, we talk about the general standard form ax squared plus bx plus c. And now there are certain cases which basically start with um, the constant term. So my first case is we factor out quadratics where the constant term is 0. So let us say if I have to factor out quadratic 2x squared minus 4x, and where the constant term you can see is 0. So here a is 2 and b is negative 4 and c is 0. So how do we factor out this quadratic basically? So obviously in this case, you look at whichever is the highest common factor in these two and you pull them out. So basically it is, if you look at 2x squared and minus 4x. So 2 times x, and you have 4 times x, which is again 2 times x. You can see the highest common factor is 2 and x and x. So 2x is the highest common factor. So you can remove out 2x common, and if you remove 2x here, you are left with x, and then you are left with 2. So it is x minus 2. So in some initial examples, you can do this procedure, but it is important that you also have confidence to do this factorization out here itself. So 2x, x minus 2 as a working. And our next part is basically let's say if I have another example I'm giving is, let's say 9x squared minus 8x. Now here you can see clearly that 9 and 8, there is nothing common. So you could take x common from here straight away. So you'll get 9x minus 8 as my factored answer. So this is the case where your constant term is 0. Now let's come to the case number 1, which is one of the important thing that I talk about is called a splitting middle term. Now the main objective is to explain splitting of middle term. So how do we factor out quadratic splitting using splitting of middle term technique? Splitting of middle term. So splitting of middle term. So understanding the quadratic of factoring quadratic using splitting of middle term will be the top priority. So let us say now I have a quadratic, which is, let's say, x squared plus 6x plus, let's say, 9. Now, when you factor out a quadratic using splitting of middle term, there are two cases. Case number 1 is where the coefficient of x squared is 1, and second case is where coefficient of x squared is not 1. So we'll talk about both the cases as well. So now why it is called splitting middle term technique is basically because if you look at, first thing what we look at is that once you verify that it is coefficient x squared is 1, after that you go ahead with the next term. So coefficient of x, so you need to find out two numbers which you multiply and they give us, so which two numbers, so let's say two numbers multiply to give 9 and add to 6. The two numbers multiply to 9 and add to 6. So coefficient, this number that you see is the product of the two numbers, and this is the addition of those numbers. So positive 6 is addition and multiplication is 9. So the two numbers, of course, that they come to our mind is 3 and 3, because 3 3s are 9 and 3 plus 3 is 9. So when we split the middle term, now in this case, let's say x squared plus 6x plus 9. So the 3 and 3, these two numbers that you got, you just attach x with them. So this 6x can be broken down as, so x squared plus 6x can be broken down as 3x plus 9. So you can see that how I'm using this part. So the sum can be broken down as 3x plus 3x. Now that's what is called splitting. Now remember that it's not a new quadratic, it's the same quadratic. If you go one step backwards, if you combine them, you get the quadratic backwards. You can cross-check always your answers. After this, what you have is, let's say x squared plus 3x, you take factor out. So x plus 3 and plus 3, x plus 3. If I take common, pair them two numbers together, and what you do is you take x common from the first one, because you can see the highest common factor is x, and the second one you take 3 common, so positive 3. Take positive 3, so that's why here it's also positive 3. So now you can see that here you have x plus 3 and also x plus 3, so you can factor out x plus 3, and at the end there is x left in this bracket and plus 3 left. So this factorization is x plus 3 the whole square. So the general observation that you would have got is that both the brackets must be the same. After splitting middle term, if any of these brackets are not matching, then your factorization is incorrect. So this is how you conclude the splitting of the middle term. I'll take one more example, and let's take the example with x squared minus 3x and minus 4 equals to, let's say I'm not equating to 0, so currently only factoring. So once again here, the coefficient x squared is 1, and I'll take first couple of examples with coefficient x squared being 1. So when I'm factoring here, now I need to find out two numbers that multiply to -4 and add up to -3. So the two numbers multiply to -4 and add up to 3, -3. So the constant term that you get is the product of the two numbers, and this number that you get here is the sum. So when you're factoring out this one, -4 is the product of the two numbers and sum is the -3. So which two numbers give me product as -4 and sum as -3? Is obviously -4 and +1, because if I multiply them, I get -4 times 1 is -4. That is verified. So split the middle term as -4x plus x. So I'm going to split this -3x as x squared -4x plus x and -4 as it is, not equal to 0. So you factor out now x common from the first one, it is x minus 4, and plus, now if you see there is nothing common, you take out 1 and x minus 4. So you can see that both the brackets are automatically came to the same. And when you simplify it, it is x minus 4 and x plus 1. So that's the example where you have you can see that splitting a middle term helps us to factor out a quadratic. Now let's take a couple of more examples with the coefficient x squared being 1. So let us take x squared minus, let's say, minus 9x and plus 14 equals to, not equals to 0 in the beginning. I'll just, I'm making a mistake. So x squared minus 9x plus 14, and let's say I have to factor this out. So once again, you see that it's a coefficient x squared is 1. So you find out the two numbers that multiply to 14, and their sum is -9. So sum is -9 and product is 14. So what we do is, basically in this case, the two numbers that come to my mind is 2 and 7. Let's see, if I add 2 and 7, am I getting 2 plus 7 is -9? No. So if I take -2 and -7, so let's see what happens. Yes, now the sum is -9. So I split this -9x as x squared minus 2x minus 7x and plus 14 as it is. Now you factor out. So if I factor out x, it will be x minus 2. Now if I factor out -7 from here, because this is -7, so -7, if I factor out, the second bracket also will be x minus 2. And as a result of this, what we get is, we get x, if I take x minus 2 common, I get x minus 2, and here left is x and -7. So that's how you factorize using splitting a middle term when the coefficient of x squared is 1. So let's take one more example where you have x squared minus 11x plus 28. Now let's say if you want to split the middle term out here, what we do is In this case, of course, the product of the two numbers that you have, so product is basically 28 and sum is negative 11. The sum is negative 11 and product is 28. Now the two numbers that multiply to 28 and sum is negative 11. So 7 and 4, obviously they multiply to 28, but they don't add up to negative 11. So start with negative 7 and negative 4. So negative 7x and plus 4x is something what we're going to split this middle term as, minus 4x. So you split this middle term as x squared minus 7x minus 4x plus 28 equate to 0. Don't equate to 0 until they ask you to do so. So it'll be x minus 7 minus 4 x minus 7. If you take x common from the first one, you get here. And if you take minus 4 common from the second, you get x minus, and both the brackets must be the same. And what you get as a result is x minus 7 and x minus 4. So this is the factorization that we get using the splitting of the middle term for the next one. Now let's take an example where you don't have the coefficient x squared being 1. So let's say if I have got 2x squared plus, let's say, 3x plus 1. In this case, how do we factor out? So what you look at is that, let's say if you have the coefficient x squared is not 1, your product of the numbers is the product of the leading coefficient multiplied by the constant term. So here product of the numbers is not 1, but it is 2. So 2 into 1, that should be the product, and sum should be 3 as it is. So now after that you follow the same step. So which two numbers multiply to product as 2 and sum is 3? Now before that, let me just illustrate some more examples. Let's say I've got 4x squared, let's say minus 3x minus 1. Now in this case, if I want to find out the factorization, the product of the numbers should be negative 4 because 4 times negative 1, and sum should be negative 3. So which two numbers multiply to negative 4 and they add up to negative 3? So let me just first give the first example. So 2x squared plus 3x plus 1, and the product of the two numbers is 2 and the sum is 3. So product of the two numbers is 2. So if I'm to look at the 2 and 1, and obviously 2 and 3 if I add up is going to be 3. So when you write down this now, split this 3x as 2x squared plus 2x plus x plus 1 as it is. And now you take 2x common from the first one, so you're left with x plus 1. And from this one also you can take positive 1 common, so x plus 1. X plus 1 you can factor out, and you're left with 2x plus 1 in the second bracket. 2x from here and 1 plus 1 from here. Now the next one is when your product is negative 4 and sum is negative 3. So of course negative 4 times 1 and negative 4 plus 1 is also negative 3. So split this middle term. So 4x squared minus 4x plus x. So you just attach x with these to get the middle term. Splitting and equals to. So now you take 4x common, it will be x minus 1 plus 1 common, x minus 1. And of course you can remove x minus 1 common. So it will be x minus 1 and 4x plus 1. So this is how you do the splitting of the middle term and factor out a quadratic. Now, if I add up one more step, basically if I, let's say, equate to 0 and I ask you to solve. So you do the same thing, you factor out all of the same, these are the same steps. So, but you just retain equals to 0. But the final step is, now since you see the multiplication of two factors is 0, so this is 0 or this is 0. So you can say x plus 1 is 0. That gives you x is negative 1. Or 2x plus 1 is also 0. That gives you x is negative half if you solve for x. So these are the values of x that make this quadratic expression 0. So if I plug in x is negative 1 here, you'll see your answer comes to 0. Similarly here, if it is 0, then x minus 1 is 0. That gives me x is 1. Or 4x plus 1 is also 0. That gives me x is negative 1/4. So this is solving quadratic when it is equated to 0. So this is how you do splitting of the middle term, factoring out a quadratic, solving equation.